All right, back for part two. It's only one example, but you know, there's some work. There's some work involved here. So let's get at it. I want to point out that really the ultimate goal in this whole chapter is this, right? We're learning maybe about some new stuff, critical points, points of inflection, but really that's the key. And we were actually pretty good at this to begin with, by the way, um, from functions. And I'll get into the derivatives and stuff in a second, but we were able to do, you know, uh, -4, +3. This is MHF4U graph. We know it's degree 4, so it starts low and ends low. This is a triple root, so it slides there. So it's going to do something like this, right? That's not bad. That's a pretty good sketch. And we actually, we fill in x equals 0 and get that y-intercept is 192. And that was functions. But we'd much rather be able to get the maximum there, and we actually can see that there's going to be a point of inflection in here somewhere too. Now that we know what that is, so let's get into the work. So the first derivative, product rule and a chain rule, right? So take the derivative of the mother function, and then the baby stays inside, then the derivative of the baby, write down the second thing in the product rule, write down the first thing, derivative of the second thing is just -1. And at this point, it is pretty important to tidy this up. Otherwise, it ends up being awful to not only set that equal to 0 so we can find the critical points, but also to do the second derivative. So it is important to tidy. So let's take out a common factor of x plus 4 squared. Then what's left over in the brackets? Both of those are gone. I've got 3 times that bracket. And a minus, notice I'm just writing this minus out front. And tidy that up inside the brackets. 9 minus 3x minus x minus 4. And if I'm making arithmetic here, please just put up your hand and tell me. That'd be great. Okay, I do have my notes here, and I'll check every once in a while to make sure that I'm on track. So first, critical points. X equals -4, and when this is 0, x equals 5/4. And so that's going to go on a sign chart at some point. Notice, here, I'll start my sign chart over here. Why not? Why not? So notice for just my function, I'm going to have my sign chart's going to end up having a whole bunch of stuff here. I can see that -4 is an important point and 3 is an important point, because that's where this graph goes from being positive to negative. Just the graph itself, right? It's negative in here, positive all the way in here. Although, as it turns out, this one we don't really care about too much. It doesn't give us too much of an idea that we didn't already have from functions. But what do we have here? We've got right there, we got -4, and 5/4 is going to be over here somewhere. That's where that's 0. And we could do the analysis on this now or later, it doesn't matter. Where is the first derivative going to be positive or negative? Well, notice that when this is -5 or -6, these values out here, this is going to be squared, so that's positive. This is a minus, so 5 minus 4 times a negative. This is going to be positive as well, so this is going to be positive. And notice we can see from the graph that it's increasing there. Of course, one of the ideas here is we're building up our skills on a function we're fairly familiar with, so when we come into contact with a function that's not as familiar, that we'll have our skills built up. What about in here? My favorite test points in here, 0. I love 0. Positive, and that's going to be positive, so it's positive in here as well. And so notice that even though the first derivative was 0, it doesn't change sign. So I automatically know right from the first derivative that there's no min or max there, right? I know that it's this weird case, and we actually have a name for that now, but we'll get into that later. For these values out here, this is going to be positive still, and then I'm going to be 5 subtract 4 times a positive number that's fairly big is going to give me a negative. And I can see from my graph, actually, after 5 quarters here, I guess that would be 5 quarters, that it starts decreasing. Okay, dandy. Time for switching colors and going to the second derivative. And notice that the second derivative is another chain rule, right? It's another chain rule. Chain rule, product rule. So let's take the derivative. Take the derivative of the mom, the baby stays inside. Derivative of the baby, write down the second thing. Plus, write down the first thing. Derivative of the second thing's minus 4. Again, I'm going to pull the same trick of factoring. This is actually not so bad. You could just expand this. It's just a quadratic now, so it's not so bad if you expanded it. I'm going to pull a 2 out too. Why not? So from this first term, what's left over is that 5 minus 4x, that thing right there. And then I pulled a 2 out, remember. There's one bracket of those left over. So what's left inside? I got 5 minus 4x minus 2x. And again, if I make an arithmetic, hands up, just so you can correct me if I make a mistake. You'll do that for me, right? And then to collect some like terms here, I get negative 6x. I should have taken a negative out here too, maybe. I still may. Minus 13, just because both of these are negatives, I could write this as factor out of minus 1, and then I got 6x plus 13. I'm checking my arithmetic here to see if I got the same thing. No, I didn't get the same thing. So what did I do wrong? What did I do wrong? Well, it looks okay. Maybe my notes are wrong. That could be. Well, if I made an error there, you can make fun of me and correct me tomorrow in class or later today in class or wherever. But now what? Well, now we want to set that equal to 0 to find the poise, point of inflection. And so what do we got? I got x equals minus 4 as a point of inflection, and x equals negative 13 over 6. About negative 2 and a little bit. And how does that match up with my graph? Negative 2 and a little bit. Yeah, sure. That's a POI. Oh, I could sell that to you probably. All right, well, let's put those points on our number line. Negative 13 over 6. When I had a 0 there and a 0 there. And let's talk about the sign of the second derivative, so we can talk about concavity. Notice that when it's these values out here, less than negative 4, that I got a negative times, that'll be a negative, times that's a negative, times a negative, times a negative is going to be a negative. Okay, but what happens when it's in here? Well, I have a negative, and then this is going to be, like negative 3 in there, so this is going to be positive. Negative times a positive times, well, this is around -3, so this whole thing is going to be negative. Negative times a positive times a negative is going to be a positive. So what does that tell me? Right there, it tells me that I have a point of inflection because the second derivative has changed signs. Okay, and that was it. Oh, we've got to fill in the rest here. So for any other value, including 0, my favorite, negative times a positive, it's going to be negative times a positive is going to be negative. And there's another point of inflection. So I have a point of inflection at x equals -4, since the concavity changes sign, and x equals -13/6. And what else do we want to do? We wanted to say second derivative test to find local minimum and maximum values. What's the second derivative test? Well, that's the idea is y prime equals 0 at x equals -4. But here, the second derivative is negative, so that's not a minimum or maximum point. We also had x equals 5 quarters as a critical point. And notice that here, the second derivative was negative. So what does that mean? Negative, frown, it means that we got a maximum. So from the second derivative test, we have a maximum at x. Well, rest all. We already knew it was a maximum because this was increasing, 0, decreasing. We knew it was that shape. Well, yeah, that's true, but the second derivative test also gives you more evidence. Another way to check your work. Okay, if you don't mind. And then now we should be able to do a good sketch the graph, right? Sketch the graph. And instead of doing that, I'm going to use the fairly decent one that I started here just to be a little bit cheatsy. And I should get the y values, but I don't care too much. I should do that. Do I have them here? No, I don't even have them in my notes. So, and this was -13/6. This is a POI. And of course, on a test, I do want you to find the y values, but you'd be able to clunk those into your calculator without too much effort. And instead of me clunking it through the calculator, I'll let you do that, or be satisfied with this question the way it is. And that's it for concavity and POI, points of inflection. That's almost it for the whole unit. Certainly, this is all that's new. This idea of what algorithm, what attack do we do if we're just asked to sketch the graph? And we talked about this a little bit last class, but this idea of what routines do we go through in order to do a calculus job of a sketch? And that's the last thing, and that's what we'll be talking about next class.